Hello, my name is Junha, and I'll be presenting about this paper. This is my index and the problem setting and motivation. Neural net architectures are handcrafted and require expertise in elaborate design. Large number of search space for these designs are necessary. And also, one typically designed network is usually limited on a specific data set. So the motivation is that we want to generate model architecture automatically. So these are the methods that I'll describe. The first is Q-learning. Q-learning is one paradigm of reinforcement learning. Before that, you should know about Markov decision process, or MDP, which is a set of states, actions, probability, transition probabilities, and rewards. Many reinforcement learning problems can be described as MDP, and your goal is to find the trajectory to maximize the cumulative rewards. So the objective function to solve this MDP can be represented as this Bellman equation, or the Q value. It is expectation of cumulative rewards until termination given current state ST and action A. Learning by optimizing Q value is called Q-learning. Important fact is that our problem of generating the best neural net architecture can be translated to MDP and be solved by Q-learning method. Each layer of neural net can be represented as a 5-tuple. So according to this table, you can describe certain layer with 5 numbers. And this small network can be represented as a list of these tuples. Also, selecting next layer can be considered as an action and validation accuracy as a reward. Also, finally, transition probability is defined as epsilon greedy exploration, which I will describe in the following slides. So this is the whole training process. You generate the network and train the network on a task, and feedback validation accuracy as a reward, and update the Q value using this reward, and iterate through this process over and over again. Next, I will explain about epsilon greedy exploration. This algorithm is used for transition probability of MDP. Random action is taken with probability epsilon, and greedy action with the largest Q value is taken with 1 minus epsilon probability. It is set to 1 at first, but it gradually decreases over iterations. This algorithm enables both exploration and exploitation. Next is blockwise generation. The paper suggests that it suffices to generate block architecture and reuse them throughout the network. This reduces the search space and the computational cost, which is one of the main contributions of this paper. Also, it is time-consuming to train the model every time until convergence. So the authors use early stopping and train the models for only 12 epochs only. This may lead to an inaccurate evaluation. So they reshape the rewards. Specifically, they penalize the rewards in the flops, and the density of a model is too large. Here, flop means computational cost of the architecture. So they use for the dataset, they use CIFAR 100. And these are the block architectures generated with this method. They call it block QNN. So in terms of accuracy, they produce SOTA results compared to auto-generated models. Also, while not the best, they produce comparable results against handcrafted models. In addition, they were able to decrease the computational cost significantly using these mentioned techniques. So in conclusion, the model proposes efficient and high-performing blockwise neural architecture search using Q-learning. It produces great models, and they were able to get this result with low computational costs using these techniques. Thank you.